about roots and rational exponents. And then I'll just say the nth root is in math. When we talk about the nth of anything, we're talking about just some future number that we pick. But we want to be able to simplify expressions involving radicals and rational exponents, and then simplify expressions in exponential and radical form. Looking here at my vocabulary as we get started, we want to make sure that we understand, what is this radical thing that we're talking about. And so finding the square root of a number is squaring a number are inverse operations. So finding the square root of a number and squaring a number are inverse operations. So here, let's just say, so when I say that, think about it when we have c squared plus c squared equals a squared plus b squared. In order to simplify this, right, in order to get c by itself, we have c squared, we find the square root of it, and then we know that the square root of c squared is actually just c. So that's why your square root and your squared power are inverses. Now, it's really just a understanding what is going on, and we'll talk more about that here. Okay, so looking at our radical, understanding what are we talking about here? The index, or should I say, we have the radical symbol. Oftentimes students just refer that to the square root symbol, and that is because anytime we see the radical without an index number, right here, my index number of n, it's understood to be a 2. So that's why we're looking for we're looking for the square root of something. So that's why we refer to it as a square root. Now here, so this could be any number, and depending on that, and this of course your radicand is what we're trying to find the roots of, and then that's really it. So understanding where those go. Now anything your radicand, unless otherwise stated, your radicand is going to be something to the first power. So thinking of that, so basically we'll do some examples here, but this quickly becomes, if I wanted to write that with as an exponent, it would be 36 to the 1/nth. These two things are equivalent expressions, just written differently, but we're going to go into that farther on here. So what does finding the square root of something mean? If I'm trying to find the square root of 16, right, it would be written just as the square root of 16. I'm looking for the number that I multiply times itself, and I know that this would be 4 times 4, which would be 4. But we got to remember that we could also have a negative root. That could be negative 4 times negative 4, because that would also give me a positive 15 or 16. So I could have negative 4. So that's why when we see something along this lines, the square root of 16, we see something that says plus or minus 4, understanding that it could go both either positive or negative. And then what they will tell you that the principal root is going to be that positive root. This is my principal root. It does have a negative, but the principal is going to be your positive. So suppose n is an integer greater than 1. So your index is something larger than 1, integer. So keeping that in mind, as we go forward here, we want to simplify. Plus or minus the square root of 25 x to the 4th. So what we find out is we know that I'm going to come up here 1, and I know that this is the same thing as the square root of 5 times 5, or x squared times, and x squared times x squared. So they're saying that technically we have 5x squared. Okay, that would be the same thing as the square root of 5x squared times 5x squared. So we have 5x squared squared. So the root of that, right, is going to be just one of these, which is going to be plus or minus 5x squared. Because it's an even root, we're going to have that plus or minus effect. Let's see. So simply, if I looked at an easier problem, I have plus or minus the square root of 16x squared. We're looking for, two items that, or an item when we multiply it times itself that will equal 16x squared. So we can break this down into, I know that 16, I got 4. 4 is the square root of 16, and then x squared, x would be the square root of that, so I have 4x squared. That's probably the easiest way to think about this, and then that would be the square root of 4x squared is actually just 4x. Trying to get smaller numbers in there so we can think about what's going on instead of being, burdened by a larger value to understand the concept. So here, in this case, we do have even roots, but the negative is on the outside, so that's just multiplying by -1 out here. Whatever my answer is, it's going to be -1 times -1. So I have this radical, the radical with this y squared plus 7 to the 12th power. Now 12, I'm looking for, again, the square root, so 12 divided by 2 is 6. So that's how they came up with this. They said, okay, if I were to take two exponents, 6 multiplying y squared plus 7 to the 6th power times y squared plus 7 to the 6th power, when you are multiplying like bases, this being my like base, you add the exponents. So that's why technically, that is simply dividing 12 by 2 to get 6. So I know then that this is going to be the square root of, with that 12 exponent. So that's what they're doing. Here now we go into the third. So now we're looking at something divided by 3. So when I talk about my variables, I want to divide them by 3. That's going to help me find that cube root. So I would have the cube root, and then I have a cube root of 343. But here, so I know that b to the 6 divided by 3 is going to be b squared. A to the 18th divided by 3, that is going to be a to the 6th. I had to get the calculator out to make sure that I know that 343 is actually 7 to the 3rd power, so that is going to be 7. So this is the same thing as, again, the cube root. I'm looking for something that I multiply times itself 3 times, and that would be, 7a to the 6th, b to the 2nd, 7a to the 6th, b to the 2nd, and then 7a to the 6th, b to the 2nd. Now we try to avoid doing that because that's a lot more work, to write that out and then say, hey, this thing multiplied times itself 3 times, so then that answer is going to be 7a to the 6th, b to the 2nd. We want to get beyond this. This is sort of juvenile, and we want to be able to understand that just writing that 3 in there. Okay, so that's what we're looking at. We're not going to do this. This one right here is going to turn out to be a imaginary number, and we are not focused on that at this point in time in the course. So I omitted these, but we should be able to do this. So we're looking for positive or negative the square root of 196 and the square root of x to the 4th. Hopefully we're understanding, and if I just say, hey, I got the square root of 196 and the square root of x to the 4th. Hopefully you can say, hey, the square root of x to the 4th should be x to the 2nd, because that would be x squared times x squared. Then the square root of 196 is going to be 14, because 14 times 14 is 196. So 14x squared is going to be the positive or negative. 14x squared is the square root of 196x to the 4th. Now, we have the same effect here going on. We just determined what the square root of the square root of 196x to the fourth is, but now we're going to multiply it by a negative number. So we have what we determined was 14x squared, and then it's being multiplied by a negative 1 out there, so you just have negative 14x squared. Now, if you were to do this one over and you've been working on your imaginary numbers, I'll just say that that is 14ix squared. And this is 17i c to the fourth d squared, just so you have it in case you need it. Okay, simplify using absolute value. We are looking here, when you find an even root of an even power and the results is an odd power, you must use the absolute value of the result to ensure that the power is non-negative. Okay, so this is x to the first, so that's why we would use the absolute value. This is some variable to the third, so we want to make sure that whatever my solution was the absolute value. So we still do the same process, we just understand that it's going to be the absolute value. So here in this scenario, when we took the eighth root of 24, that became to the third power. So the third power was that odd number, so we want to make sure that we have the absolute value. And then here we did not need to identify that because the eighth root of 256 is going to simply be 2. So we can actually find this portion of it, it's 2. And that would be multiplied by whatever resolution we have in the absolute value. Let's see here. Rational exponents. Okay, rational exponents. Now, I'm all about using rational exponents because I think it really makes doing the radicals much easier. What we learn here is the expression is in exponential form if it is in the form of x to some exponent. So we're talking about the exponent. So looking at this, the way we do this transformation is, let's look here. We recognize that this is my index, and this is my radicand, and this is my radical. Okay, well, think about what's going on here. My radicand is now the base of my exponent, and n, which was my index, is now the denominator of my fractional exponent, and then this is technically a 1 right here, which is now the numerator of my exponential, or my in exponential form. So if I have the square root, and we know then this is a 2, of 17, that is 17 to the first power. Okay, so we would rewrite that as there's my base, and then this 2 actually becomes the denominator of my 1. So then it would be to the 1/2. So it's just being able to manipulate that form to move from radical to exponential form makes things a lot easier. I ain't gonna lie. So here when we have going backwards, or the other way, when we have 125 to the 1/3, this 3 goes into the index. We move that 3 to the index, and this is technically still 125 to the first. Okay, so being able to move back and forth between those two forms. For any non-zero number b, okay, so this is a non-zero number. Y is greater than 1, so it's not a negative. My index is not a negative number, or 0. And then except when b is less than 0. So except when b is less than 0, so we could have a negative number inside the radical. So just thinking of these different things. So in this, again, this denominator becomes my index, and then I have that, my radical forms. So let's see. So 125 to the 2/3. Again, that should be something along the lines of 125 radical to the cubed. So 125 squared. And if you were to put that in the calculator, of course, it would tell you that that is 25. Simplest form of expressions with rational expressions. It has no negative exponents. It has no exponents that are not positive integers in the denominator. It is not a complex fraction. Okay, yeah, we're not dealing with that. And then the index of any remaining radical is the least number possible. Okay, so looking at these, being able to manipulate these two, and I will tell you that this we can put into the calculator. This fractional exponent we can put into the calculator, but being able to manipulate back and forth between the forms, again, this denominator becomes my index. Bring it over here, make it my index. In this case, my index becomes my denominator, so I would have x 2/5. Okay, just being able to work back and forth. Now let's see if I did this. I have the square root of x is equal to, again, this is 2, this is a 1, is equal to x to the 1/2. Okay, so keeping that in mind, that's what that is. Now, earlier when I gave that example that I have c squared, and we find the square root of that, the square root is the same thing as c squared raised to the 1/2 power. So now when I multiply my exponents, because I have a power raised to a power, that just becomes c to the 1st. So that's why it's an inverse, and that's how it works. So here, using rational exponents, so we have this expression, c times 1 plus r raised to the t can be used to estimate the future cost of an item due to inflation, where c represents the current cost of the item, r represents the annual rate of inflation, and t represents the time in years. Write the expression in radical form for the future cost of an item 3 months from now if the annual rate of inflation is 4.3%. Some things we have to remember, 4.7%. In order to go from percentages, you need to make sure that you're moving 2 decimal places. We'd go 1, 2. So that is going to be, my decimal is 0.47. So looking here, and it says for 3 months. So if t is my annual interest rate, 3 months is 1/4 of a year. So that's how they came up with 1/4. That's my exponent. My time is 1/4 of a year. So they just filled that information in, and they went ahead and did some manipulation here. They combine like terms. So they have c times 1.047 raised to the 1/4 power. And they wrote it in radical form. So again, the decimal simply becomes the index. I'm sorry, the denominator simply becomes the index. So, and here, remembering that when we talk about evaluating rational expressions, that when I have a negative exponent, that is, in order to have a positive exponent, we have to flip it over the fraction bar. So 32 with the exponent of negative 2/5 is actually 1 over 32 with the exponent of 2/5, positive 2/5. And now we can simplify this. This would become 2 to the 5th. So 2 to the 5th raised to the 2/5 power. Again, we multiply powers to raise to power, so that would be 10 over 2. So this is actually 1 over 2 to the 10 over 5, sorry, which is actually 2. There you go, being able to simplify those expressions. Simplify expressions with rational exponents. This is where I feel it becomes a lot easier for those of you who are comfortable with fractions. When we multiply like bases, you add the exponents. So you take 2/3 and you add it to 1/6. 2/3 plus 1/6 is the same thing as 4/6 plus 1/6, which is 5/6. So there you go, we add the exponents. Again, here we are reversing, making it a positive exponent, which puts this y into the denominator. And a few pages back, it did tell me that I had to have an integer. So in order to turn 2/3 into 1, we added 1/3 to it. You can't just add 1/3 to the bottom, though. We had to add y to the 1/3 to the numerator also. So this became y to the 3/3, this became y to the 1/3, and y to the 3/3 is simply y. So you have y to the 1/3 over y. And last but not least, here we have a negative, we have a positive. So again, when we have like bases, we add exponents. So we ended up with negative 1/3 plus 3/4. I had to find a common denominator of 12. So I multiplied this times 4. So I have to multiply this times 4. So I have 4/12. Multiplied this times 3. So I multiplied this times 3. I have 9. So 9 minus 4 is 5/12. So that's how they came up with 5/12. And that is working with our rational exponents. And we'll do a little bit of practice, but again, probably the hardest part for us will be fractions.